Hi all. So today we are going to discuss device drivers and interrupt service mechanism in RTOS. So so let's check what is interrupt latency. So interrupt latency is the period between occurrence of a interrupt and the start of execution of the ISR. ISR means interrupt service routine. So actually, if an interrupt occurs, there should be an ISR associated with that interrupt. To service that interrupt, it should have an ISR. So, there is a time gap between the occurrence of that interrupt and the start of execution of the associated ISR. So, such a time period or such a gap is defined as interrupt latency. The time taken in context switching also, you have already studied about what is context switching. So the time taken in context switching also included in a period called interrupt latency period, which is indicated as T lat. Okay, so minimum interrupt latency period. So T lat is the sum of the period as, so it is find how it is found out. T lat is equal to time to be taken is for the response and initiating the ISR instructions. The time which is taken for response and to initiate the ISR instruction. This may also include the time to save or switch the context. That means the context must be switched from one task to another. So that time is also included, plus the time to restore its context. Okay. So it may include the program counter data and the registers. So this is an example for TLAT. So minimum latency equals context switching period. So when the interrupt service starts immediately, that means the ISR services is started immediately after the occurrence of the interrupt, then the T switch, that is the context switching time T switch equals to is denoted as context switching period. So when instructions in a processor takes variable clock cycles, maximum clock cycles for an instruction are taken into account for calculating the latency. So when a when there are multiple instructions are inside the clock cycles for running, so the maximum clock cycle for the instruction should be accounted for calculating the latency. So this is how the latency in case of interrupt service starting immediately. So here you can see at the time T0 the interrupt occurred at the processor. As soon as the interrupt is occurred, the ISR is started immediately. So it takes only a T dash for context switch time. So T0, that is the time at which the interrupt occurred at the processor, that is T0. So T0 plus T dash, so that is the latency, that is which the ISR is started very immediately after the interrupt occurs. So here the interrupt latency is equal to T dash only, where T dash is the context switch time for saving, running the program context and loading the new routine context. So interrupt latency is equal to only T dash. That means only T dash of the time is taken there for the context switching. Okay. So next case is the latency on context switch to a higher priority interrupt. That means whenever a higher priority interrupt occurs, let's check how it will affect the latency. So when the interrupt service does not start immediately by context switching, but context switching starts after all the ISRs corresponding to the higher priority interrupts complete the execution. So in that case, that means whenever a higher priority interrupt comes before the context switching happened, then the sum of the time intervals for completing the higher priority, that means the time for completing the higher priority ISR equal sigma TechSec. Then interrupt latency is calculated as T switch plus sigma of T execution. T execution is called Tx. Okay, Tx is the execution time for the ISRs, and T switch is the time for the context switching. Okay, then interrupt latency is find out by the formula T switch plus sigma Tx. So this is how it occurs. That means so at the processor, when a higher priority interrupt event occurs at T1 after the T0, so it started at T0 plus T dash. T dash is the context switch time. Then the ISR of the higher priority is running inside the processor, and it will finish at the time T2. So then the another ISR will only starts after the T2 plus this T dash is the context switching time of in between these two ISRs. Okay, so here the interrupt latency is find out by the T2 minus T1 plus T dash, where T dash is the context switching time. So next case is latency due to execution of disable interrupt instruction in a critical section. So inside the critical section, you are having a interrupt instruction. So suddenly the interrupt has to be disabled from the critical section. So let's check how the latency is affected in such interrupt instruction disabled. Here, T disable is indicated as the period for which a routine is disabled in its critical section. So, the interrupt service latency from the routine with interrupt disabling instruction, that means due to the presence of the routine with critical section for a interrupt source, will be calculated as T switch, that means the context switching time of interrupts plus the sigma t execute, that means execution time of the particular interrupt, plus t disable. So t disable is the period of which a routine is disabled in its critical section. So this is how it is pictorially represented. Here interrupt latency is find out in this formula, that means sigma t execute plus t disable plus t switch, where t switch is the context switch time. So next is the worst case latency. So you have already heard about worst case latency in several topics. So worst case latency is the sum of periods t switch, sigma t execute and t disable. Okay. So next is the minimum latency. So minimum latency occurs when the interrupt is of the higher priority, and it is the sum of the periods t switch and t disable. So next is ISR or task deadline. So that means that for every source there may be a maximum period only up to which the service of its all ISR instructions can be kept pending. So this period is called deadline period, and which is indicated by TD, and the execution must be completed before TD. That means only up to a particular instance we have to keep these ISR instructions um, in the source. So after that, so before that deadline period, it should be completed. That ISR should be completed before the deadline period or before the particular period. That period is called deadline period, and it is indicated by TD. So this is how it is indicated. That means here is an execution of a routine, and there is a context switch time for next event ISR. So this routine have to be particularly in finished before this TD. Okay. So interrupt latency should be such that a deadline of a new event ISR is not missed. That means this new event ISR is not missed. So we have to put a deadline for the previous routine. That is how it is indicated here, and this routine must finish at the time TD. So this is another example. So how the deadline is maintained. This is an example. That means in a video conferencing, the video frames are reached in on by 15 seconds. So the device on getting the frame interrupts the system, and the interrupt service deadline should be on by 15 seconds. Else what happened? Else the next frame will be missed. So the devices should be in the synchronization in on by 15 seconds, else the next coming frame should will be lost. So this is in latency, and next we have to check on performance metric. So performance metrics means, so we have to determine the performance of the RTOS. So we have taken some measures or some metrics for determining the performance of the system. So that is called the performance matrices. So we are taken some models for performance measures. The three types for tasks for finding performance. So scheduler must take into account three types of performance tasks: a periodic, and sporadic. So a periodic task means it needs to run only once, and a periodic task means it needs to run after a fixed period, and that it must be executed before its next preemption is needed. So it is what similar to a round robin scheduling. That means after a particular time slice, the process is preempted from the ready queue, and it is inserted into a queue. So that is called a periodic task. So a round robin scheduling algorithm is actually an example for a periodic task. And third one is a sporadic task needs to be checked for run after a minimum time period of its occurrence. So next is predictably responds to the event and minimum interrupt latency as performance measures. So, RTOS should respond very quickly on an event. Okay, so it should kept the minimum interrupt latency and will be the fast context switching latency. Okay, that means the task have to be switched context switched in a very fast manner, and in between the interrupt occurrence latency, that is interrupt latency, should be minimum in an RTOS. So three models for the performance measures are: first one is ratio of sum of latency of the task and interrupt with respect to the sum of execution times, and second one is CPU load for how much time CPU not idle, and third one is the worst case execution time with respect to mean execution time. So interrupt latency as performance metrics. So interrupt and task execution latency with respect to the sum of execution times must be very small. So interrupt latency in an RTOS will have to be very small for the better performance of the system. That means it should have a very fast context switching. So next is CPU load as performance metrics. Each task gives a load to the CPU that equals the task execution divided by the task period. So the CPU load or system load estimation in the case of multitasking is as: suppose there are m tasks, and for the multiple tasks, the sum of the CPU loads for all the tasks and ISR should be less than 1. So it should be noted that if there are m tasks, then for the multiple tasks, the sum of CPU loads for all tasks and ISR should be less than 1. So if the CPU load equal to zero point 0.1, that means 10%, means the CPU is underutilized and it spends its 90% time in a waiting mode. So if it uses 1%, that means it means 100% the system is very efficient and it doesn't need any waiting mode. Since the execution times can vary on different task periods, the CPU loads can also vary. Here is the sporadic task model performance metrics. Here the T total is equal to total length of periods for which the sporadic task occurs, and E is the total task execution time. TAV is the mean periods between the sporadic occurrence, and T min equal to minimum period between the sporadic occurrences. So this is how the worst case execution performance matrix P is measured. That is P equal to P worst equal to E star T total by T av whole divided by E star T total by T minimum. So that's up to our fourth module RTOS. We have all covered almost all the topics in the fourth module. So okay, thank you.